all of y'all. How y'all doing? So I'll be talking about the big satellite that'll be coming in a bit. And let me share my whatchamajinky, my PowerPoint first. Did I close it? I think I did. For those who were who just joined, I have an update to my hold up. That's the one. Oh, what's up? Interesting. Well, I'll get the hang of this eventually. Oh, there we go. Now it's showing. So I think now that's it. There we go. So for those who just joining for the normal time, I added a new uh, honors to my Jinky there. I got honors in the fall again, so excited about that. Ended up these are my grades for the semester, so did pretty well. Excited about that. That was my reasoning for not being here last week. I was so spooked from my final exams. So next semester, I'll probably just plan for a no stream that week on finals week. But yeah, did pretty well. Got university honors again. That's what this is up here. So any semester that you earn 3.5 or higher, you get university honors. If you take so many, you have to be full time. That was more than full time. I took 15 hours. All of them hard classes. Even though the research classes were pretty straightforward, but you did have to learn a lot of coding and how to ask research questions and present things. I did presentations for each one. It was involved as well, but it wasn't like as complex as quantum or as intricate classical electrodynamics. We even was doing relativity. And Lisa says, I bet that quantum physics was nasty. And she says, Red's Reddit channel showing Jupiter Live really cool. So maybe I'll check that out. Rez is cool. Maybe I'll look at that after this one ends. Thanks for showing up to this one, Lisa. Yes, quantum was difficult. It gets challenging. Quantum is not what. All right. The way quantum works is it's based a lot on probabilities. So like for instance, if we have maybe I can break on my pad a little bit. Talk a little bit about it. So we have enough time. Give me a moment here. I didn't plan to break my pad out. So give me a moment to log into my Discord. I'll talk a little bit about the difficulty that is quantum, what makes it hard. Some screen and let me join here and here. Boom. So when I share my Discord, I just let it grow. I just let my hair grow as all. Uh, uh, we, there you go. Yeah, just let it grow. Uh, I guess during the wintertime, I find it's customary for me to let my hair grow a bit because I don't like the cold. So during the winter, I will let it grow out a bit to at least have something on my head. But that's all. And you just see the male pattern baldness going. Uh, and usually I have a hat on too, so I probably should have just ran my comb. Usually I'm wearing a hat, but yeah, it's just all fuzzy and growing out some. And this is like a bald spot coming here, like like male pattern baldness. So usually I shave it, and but I think in January I'm not going to even shave it anymore. But yeah, that's all it is. It's just fuzzy and growing out. But I don't know. I like having hair, even though I don't have as much of it, but but I still like having hair on my head a bit too. So I noticed as well, by the way, that when I shave my head too much, it starts irritating my skin. So that's another reason I have to let it grow too. It starts irritating my skin, so I just let it start growing again. Uh, uh, but yeah, that's all it is. It's a bit fuzzy, but boom. I can see if I could get some of the fuzz out of a little bit. But yeah, that's just the way it is, though. I think I believe it was Catherine asked me if it was a hairstyle or if I was doing the reverse of MC Toon, because I believe MC Toon cuts the sides of his head and has the middle sort of spiked. And she had asked me, like, are you doing the reverse of that? Like, are you like cutting the middle? At least it seemed like she was asking, are you cutting the middle and letting the end stay out? And I was like, nah, it's just Mother Nature. It's just the male pattern baldness look, and Mother Nature is my hairstylist. That's all that's going on there. Yeah, that's all that's going on. So, the camera doesn't show it very well. Baldness look good to me, by the way. Never understood why some people made such a big thing. Well, that's good to hear. I remember one of my favorite TV shows is The Next Generation with Star Trek. And I remember when MC Toon, not MC Toon, I just noticed that MC Toon sent the message. I'm responding a bit. So maybe I'll say that. I noticed when uh, uh, Patrick Stewart, when Patrick Stewart was getting the part and uh, somebody had asked him in an interview, you know, in the future, didn't they cure baldness already? Like, how is a bald dude going to be the captain? I mean, why is there even bald people? It was something like that. And he was doing an interview with Gene Roddenberry, and Gene Roddenberry cut in. Oh yeah, TNG is my favorite, right? I mean, I love Star Trek in general, even though I think the newer ones they just become just woke nonsense. So I don't like Discovery. I just got tired of it. But back when Star Trek was just Star Trek, when it was just about the story and the technology and the hope for the future and all that stuff, TNG is my favorite, right? And so I love it. I saw it at least twice, the whole series. And Gene Roddenberry jumped in, and he was like, "In the future, they don't care if you're bald or not." That's what he said. And Patrick Stewart was talking about how he really appreciated that Gene Roddenberry saying that. He's like, in the future they don't care if you're bald. So it's not like they have this line of hair products to get rid of baldness because they don't care, right? They just don't care anymore. They're not trying to dye their hair or anything. And Lisa says a bit too woke, but good stories. But the original TNG faves, yeah. Yeah. I think that I haven't looked at any other ones, but I know Discovery was too woke. And I don't even like using the word anymore. Is it too delusional? You know, too pushing of an ideology? Because woke, I think they hijacked that word, so now I mean the opposite of what it really stands for. But yeah, I just got tired of it. But my favorite ones are Voyager, TNG, uh, Deep Space Nine. It's good. If I was to rank them, I would say to be TNG, then Deep Space Nine. No, TNG definitely, and probably I don't know Voyager and Deep Space Nine. I guess I guess I would have to say Voyager, only because it's really in space. Like I really like the deep in space aspect. DS9 was in space, but it still was mostly stuck on DS9. So I think that's the only thing that will push Voyager above DS9. DS9 is still good, and I liked it, and I saw the whole series. But you fall in love with I want to go journey into space, so that's why. Yeah, exactly. He's just saying the wokeness is overshadowing the story. Yeah, it's all about pushing propaganda. The same thing with what is that? Um, where they have that V serum that make people super powered. Uh, the boys. I started watching that too because it started. The last season started to get just more and more woke. It's like, dude. And then I saw an interview with one of I guess the showrunners or whatever, and he said he was always woke. I guess it was just more subtle. And he was talking about the different ways that he was making, uh, uh, what do you call it? Homelander stand for corporate America and stuff. I don't know. I started watching that too. Yeah, Jake was good. Yeah, good show, man. Yeah, it was a good show. I liked it. Um, there's always somebody who leaves. Like I remember in TNG, that chick that played the security officer before Worf, she left, and then Dax left. I don't know. I don't know why there's some people left. I got on TNG, the older TNGs or DS9, but I would never want to be. But that's me. But also, I'll do a little bit of quantum. Why is so strange, right? So if you have a particle, like if this is a particle, okay, quantum, and we have an axis, X, Y, Z, right? If you have the momentum of the particle, so if the particle is moving and it has a certain momentum and it has a certain position, right? Because it's here on the y-axis, here on the z-axis. I guess that technically that's the. How would I put the? I guess I would have to make this a bit longer. Like it's oops. Like imagine a particle is floating in the air here. So these are the points that connect it. And I need to draw these lines better. Hold up. Let's say the particle is hovering over this point right here. So this will be the z part, this will be the x part, and this will be the y part, right? This is where our particle is hovering out in space right there. And it has a momentum. So it has an x, y, z coordinate, and it has a velocity, so it has a momentum. So momentum is just the mass times the velocity. And we can actually give it a momentum. So let's say this is moving in the y direction. So it has a momentum in the y direction. We could not measure the y position and the y momentum at the same time. We can't do it. It's just the way that awesome. Lisa says you're speaking my language. Yeah. So glad we agree on some Star Trek stuff. So Star Trek is a good bond. I'm gonna have to bring. I wrote a poem that was published in my community college paper about Star Trek and Star Wars. Matter of fact, I'm gonna show that poem next week. So next Saturday, it'll be some poetry before I talk about science. And I think y'all enjoy it. But if you were to measure these two, we can't measure them at the same time with definite value. So if we had like P, Y, and X, we can measure those two at the same time definitively, or P, Y, and Z. But if we have momentum in the same direction as uh, position, we can't measure them at the same time with accuracy. And the idea is that if we have a standard deviation, let's say, of position and momentum in the x direction, the multiplication of these standard deviations is always going to be greater than or equal to, I believe it's h bar over 2. Is it h bar over 2 or h bar power over 2? One of the two. But let's say it's h bar over 2. So there's always going to be, but you know, if we had like sigma x and sigma gy, those could be 0. They could be very precise. So, you know, maybe that doesn't make sense just in and of itself, but suffice it to say that because we can't measure these things accurately, we end up having to get probabilities. So, for instance, we would get a probability if we have a y-axis and we have a wave function. Uh, Basically, we would have to measure the probability of the particle being somewhere on the y-axis. And let's say we will be more likely to find a particle here because it has the highest probability. And this line here might be our standard deviation. So this right here might be minus sigma y. The sigma that I mentioned before is like a certain deviation or distance from the average. And this might be positive sigma y. And this will be the center point at 0. And this will be a probability distribution that we have of measuring that particle at a certain place. So it ends up, I think that's what makes it difficult. You know, I was never really interested in statistics a lot. But ironically, I'm going to need it a lot because in astrophysics, currently, statistics is very important. So I'm going to need it for astrophysics. And I'm taking Quantum 2 this upcoming semester. I can show you what classes I'm taking if I pull that up momentarily, but I'm taking like Quantum 2, relativity, taking a few classes. And so it's going to be interesting. But yeah, so that's that. So, and what's the intro thing? I was talking about my grades a little bit, what I did there. And let's talk about what I'll be talking about this talk. So what I'm going to do is bring up my that web page that I had up earlier, and we'll talk about that a bit. There's one of the videos I was looking at where it was talking about one of the another satellite that's out there, and I found that there's this satellite called the Epic satellite. So this is a satellite here that's at a Lagrange point. So we'll talk a little bit about this satellite, and I'll talk about Lagrangian points, which I think is an interesting concept. And I don't remember which video I saw this on, but it was just somebody was talking about all the different satellites that we have out there. Let me, maybe that's what it is. Maybe the filter is causing this thing to change size a bit. I guess that's what it is. It's the filter. Whenever I turn the filter on. So if we look at this satellite, oh, and Lisa says, what's the probability you'll need statistics in astrophysics? 100%, actually, 100%. 100% I'll need it in astrophysics. Apparently, and I don't even know how yet. I guess I'm going to have to see after I finish taking a class, but just looking into it a bit, the thermodynamics part is more for engineering, and the statistical dynamics part is more for astrophysics and another topic. They just gave examples, but yeah, apparently I'll need it a lot. I don't know how yet, but I'll see. But it's one of those things like, well, I want to do astrophysics, so I guess I'm gonna have to bite the bullet and get good at it because that's what I want to do. So I'm gonna have to get. I'm just gonna focus on. I was planning on focusing more on the thermodynamics part, but I'm gonna have to focus. I guess I'm gonna have to focus on both. So we'll see how that goes. But yeah, this satellite is actually at a Lagrangian point, and I'll bring up one of my textbooks and we'll look at that. But looking at the satellite, it says the Epic Earth holochromatic imaging camera is a 10-channel spectral radiometer on board NOAA's DSCOVR spacecraft. Epic provides 10 narrow-band spectral images of the entire sunlit face of the Earth, utilizing 2048 pixel CCD detector with a 30-centimeter aperture. So this is another satellite that's far enough away from the Earth where it can get pictures of the entire Earth at one time. So I don't even know how many. I used to focus on the Himmerari so much because that's the one that I knew about mainly. But there's no telling. And I know we have the Mars orbiter out there that's taking pictures. But then there's this satellite too. So I thought that was pretty interesting. So this is what it looks like on the right over there. You can see the detector housing, mid ring. It's all the CCD in the front. And this thing can take pictures of the entire Earth at one time, which is pretty good. Now, this is the picture, and I'll actually show you another picture as well. I'll actually put one of the pictures in my background here, so we can see what the pictures of this thing look like. So this is an example of an epic image of the Earth. So this is an image from the epic satellite of the Earth taken all at one time, right? So this satellite is awesome, right? So this is on par, I believe, with the Himmerari images, how it looks, right? So looking at this thing, let me adjust it a bit. And this is an epic picture from not too long ago, a few days ago. It takes pictures at a regular basis. That's what they say, right? If you don't have a picture, is why you don't have a picture. If you have a picture, then it's CGI, right? So you can never win with these guys. It's just nothing but just denial and delusion, right? But I mean, I believe that's awesome, right? There's the North American continent right there. So we can see Mexico here. We can see California on the left right there. I believe you can see my mouse. Can you see my mouse? No, you probably can't see my mouse, can you? I'm not sure, but ironically, that's what they said for the. I was looking at one of those videos in that playlist. By the way, all the playlist is public. Conspiracy cast was talking about how some of the flat earthers were saying the final experiment is proof of flat earth. Just like, dude, with people, you're never going to win, right? It's just no matter what you do. Just like Witsit, right? He just makes up something or just finds some random link, like that link he pulled in our debate that said the sun was 93 million miles away. That was his proof of a flat Earth local sun that's a geocentric. It's like these guys just I don't know. I really don't understand how they can get away with it within themselves. I don't even see how they could function like that. It is amazing to me. Yeah, so I mean that's the thing about it, and that's what making me less and less willing to try to keep up with their lies. Because, like I said, Lisa, there's always a new lie. I mean, it's like if we look at our fiction, right? I thought about this before. And thanks for letting me know the mouse is seen. Yeah, still getting used to where the mouse shows. Some things it shows on, some things it doesn't. But I was able to zoom and y'all was able to see it. But looking at our fiction though, like how many Supermen are they on now? I'm not even interested in watching it anymore because why don't you just? I wish they just kept Henry Cavill and developed the story. And that is a whole new Superman again. I'm like, dude, it's starting to get old, right? But they could keep making a new version and a new version. So there's no limit to how many lies these people can make. There's no limit to how many ad hoc explanations or how many random links they can pull and pull up and pretend like it supports what they're saying. So that's why you notice I'm just focusing more and more on just science and perhaps debunking what they say and addressing it in that sense. But trying to follow and point out their lies is a losing battle because apparently the flirts don't care. If they did, Witsit's channel would have zero subscribers now because he's been shown to be wrong so many times. And according to him, like I showed in my own video, he's a liar because he's changing his position. That's what he said. So there's not really a point. Uh, exactly, right? So I don't know. It's making me lose interest, man. So I wish they had just kept Henry Cavill. And that's one of the big things about Marvel. Like they actually developed their stories. They, uh, had a long. Oh, this is my son pick, by the way. They had a nice, multifaceted, integrated storyline that they took time to develop. It took about 10 years for them to get to Infinity War, right? And it seemed to me like DC was just trying to catch up and run to it really fast, but I don't know. But that's the same thing like a fighter. It just gets old. Like then you show them proof and they just lie and lie. Yeah, it's pretty. By the way, Lisa, this picture is now featured on floor 15 of the Physics, Math, and Astronomy building at UT. So they sent an email to all the physics majors and said, "Hey, we're gonna make a display to put students' pictures up, students' images up." And I sent in this picture of the sun, and it made the cut. So it's actually up on floor 15. If you ever made it to UT and went to the physics building and went to floor 15, it's on there. And I actually took a picture of it so I could have a picture of my picture displayed on the floor. And I knew I was getting some. Yeah. I'm officially a astrophotographer now, right? So it's like that's like my favorite picture of the sun. Well, from the fact that I took it, but you know, it's a pretty detailed view. So that's months of work right there. It took 8 months to get good enough with my camera and my telescope to take that picture. So I really like that picture. Going back to the there, boom. So I'll show y'all one of the pictures in depth. Now let's talk about the Lagrange point, what the Lagrange point is. Now let me put my book in a convenient place. Boom. So let me adjust this again. Right. So this is one of my textbooks. It's called Astronomy Today. Y'all have seen this book before. I guess it's my favorite astronomy textbook now. And in it talks about the Lagrangian points. And what the Lagrangian point basically is a point in the, well, I guess I should say around the sun. And I can actually increase the width of this, I believe. Can I increase the width of this? I guess I can't. Okay, zoom in some more. There we go. So if you look at this image here, you can see 5 Lagrangian points there. And what happens is, like this example they use in Jupiter, initially, apparently they thought only Jupiter had Lagrangian points because they noticed a meteor or asteroid or something trapped in one of the Lagrangian points, right? And if you can see, we have a 60 degree angle. So it's basically 60 degrees to the left, 60 degrees to the right. In the rear, where you can see L3, in front where you can see L1, and then behind the planet L2. So now we know that every single planet has a Lagrangian point. So that's L3, L5 right there, L2, L1. This is the sun, and in this example, this is Jupiter, but every single planet has one of these. The question is, the angle of L4 and L5 always 60 degrees for any two bodies? Yes, that's my understanding. My understanding is that this angle will always be 60 degrees, always be 60 degrees. And that's just what we find in nature. That's just the way it works. So it'll be 60 degrees on either side. And it's just because of the forces. So what's going on is the gravitational force of the sun is balancing with the gravitational force of Jupiter in this example. And it just so happens that, so one thing to keep in mind, by the way, is, and we had to study this a bit in my classical dynamics class, when you're dealing with orbital mechanics, it's not just the fact that there's a gravitational force pulling on the planet, keeping it in orbit. You also have to look at the potential. And so just like there's an electric potential, there's gravitational potential. And the reason why Jupiter is where it's at is at a gravitational potential that allows there to be a balancing effect where it doesn't fly off into space or crash into the sun, right? So there's a specific distance where that potential balances out, and that's where the orbit is. And it also means that at that particular potential, at that distance, the interaction of the gravitational force between Jupiter and the sun balances out such that at these 60-degree angles, the gravitational force is balanced so that at that point, there's a net zero force, so it could just sit there. It's almost like the two gravitational pulls are balancing to hold something in that place. So if something just happens to slowly enter the solar system and pass into a Lagrangian point, it can get stuck there. If it's not going too fast to fling out, right? So yes, it's always at 60 degrees for every single body, whether it's the sun and the Earth, the sun and Jupiter, the sun and the moon. It's 60 degrees. So it's pretty interesting. Now, the reason why this is important is L1. That's where the Epic satellite is. The Epic satellite is right now situated in L1. And that's why it only gets pictures of the day side of the sun, because it's literally facing the day side the day side of the Earth, because it's literally facing the day side of the Earth at all times, right? So that satellite, that's where it's at. It's literally right there in a Lagrange point, and this object is there taking pictures of the Earth, which means that every time, matter of fact, thinking about it, that means in my picture of the sun, it might even be there. Thinking about it, of course, it's too small to really make out, right? Because they give a distance, by the way. I believe I don't remember where I saw the distance at, but it's like like a million miles, something like that, like a million miles away. The Lagrangian point, so that's pretty far. I mean, of course, this image here in the book is, of course, not the scale, right? But it's like a million miles away. So it's like a million miles from Earth, and then like 93 million miles from the sun. I'm sure 92 million remaining miles from the sun. So it's pretty far away. I mean, it's not close at all by any means. But once it gets there, it could just stay stuck there. Which I wonder if we want to decommission a satellite. I mean, I guess it doesn't take much to move it out the Lagrange point since it's balanced. Yeah. And I've actually seen them make arguments like that, right? It's crazy. Oh, yeah, matter of fact, when I was debating Wotan, we ended up getting on the scale thing, right? He was doing something to that effect, trying to debate the scale. But yeah, it's is amazing, man. But yeah, most of them, right? But I'm trying to focus more on the ones. There are some intelligent ones that's just ignorant, right? Like the ones that get out of it, like Ranty's pretty intelligent, but most of them do seem pretty dumb. I mean, but I don't know. Do you think, Lisa? Uh, let's see. Like I remember I was joking one time, and I said that if you take some of these people, if you take them into space, like if you literally put them on a rocket and flew them into space, still they would say it was fake. They would say that there's fake TVs in the windows and stuff. And I kid you not. I wish I'd have saved what the debate was, because I can't find it again. But I'm pretty sure it was Iron Horse said the exact same thing. Somebody asked him, "Well, what would it take for you to believe it? You know, if they brought you to space, would you believe it?" And he said something to that effect, like, you can't really be sure because it could be a sound stage, and you might be, that they could put TVs in the window. He actually said that. So, I don't know. I mean, what do you do, right? I mean, what do you do? So, but yeah, but let me know what things you're like for me to debunk, and I'm going to spend more time debunking stuff and focusing more and more on the science, because that I find enjoyable, and it helps me with school, right? Rather than hunting down these people's quotes and stuff, and then they're just telling another lie like whack-a-mole. It's just pointless, you know. But awesome. That's pretty much all I wanted to talk about, just to discuss the Epic satellite. It's another satellite people can look into. By the way, let me put that link in the chat if anybody wanted to look into it in more detail. That's the Epic satellite that produced this picture here. Beautiful picture of the Earth, and it takes very regular pictures on the sun side of the Earth. That's why it's a full sun side. The Himmerari actually, it's in geosynchronous orbit, I believe they call it, over Australia, Japan type area. So therefore, the Himmerari gets day and night because it's literally going around the Earth as it spins. But this one is just stuck on the day side, facing the Earth. So what's happening is the Earth spins, and we just see the daytime side of the Earth constantly spinning underneath the sun. So it's quite interesting that you can get the Himurari that has the same part of Earth spinning through day and night. And this satellite, you get all daytime with the Earth spinning through that. I mean, it's that I just now thought about that juxtaposition. I think that's pretty cool. Lisa says it's easier to concentrate on things that are simple and intuitive to debunk. Esoteric arguments like thermodynamics are hard to make points because most people don't understand those laws. That's a very good point. As I start on a chapter of that, I am going to spend a lot of time breaking it out. And you're all right. I mean, like in the debate, like the debate technically is scheduled for January the 11th. I still have to get confirmation from Modern Day Debate, but me and Flatsword agreed on it. But how much can you really go into, right? Like you said, people are not versed in it, but yeah, I don't know. I have to think about that. That's a good point, Lisa. I'm pretty sure what I'll probably have to do is just parse out the core elements of it and make sure that those are well understood, and probably go with that. What simple things come to mind, Lisa? What simple things come to mind to debunk or show as proof of the globe? What's an example of what you mean? Interesting. So it's like Emirati. Yeah, Emirati was my favorite satellite, but now it has competition because its Epic is awesome. Okay, gravity, stars, visual, distance, and angular. All right. And you're saying visual and angular distance to the stars? Okay, I shall do that. I'll make a note of that. So, I know next week I'm going to talk about that point, which is going to not take much time. Maybe I'll talk about that next week. How do we know the distance to the stars? Things in general, like and two things in general, like to the horizon. All right. How far it is to the horizon? You mean? Making a note of distance to the stars. First, we'll tell you what things they are using to prove Earth flat. Each proofs will be good topics. I thought about looking at the debate thing, but yeah, that's why I got a few of them from some of their videos. I asked around, what's the main ones? Because some of them, of course, they run from them after we disprove them. It's awesome. Thanks for those tips, Lisa. I shall look into those. Distance to the stars, visual angular distance, gravity, uh, distance to the horizon, things over the horizon, and I'll see what things the search are talking about nowadays as far as proof for flat Earth. Oh yeah, Tune's awesome. So keep that in mind. It's awesome, y'all. Good being here. Good seeing y'all again. Thanks for showing up, Lisa. Good seeing you always. Thanks for everybody else who's shown. Looks like we had 16 views. Be sure to chat and drop a line on those who are watching. And like, subscribe if you haven't already. I have a Patreon you can sign up for free. Also, a paid subscription would be appreciated. And I'll be back next week. Awesome. Thanks, Lisa. I appreciate it. Y'all have a good one.